Hello and welcome back. In this lesson, we are going to learn about kinetic energy in a little bit more depth. So, let's get started. What do we mean by kinetic energy? Kinetic energy is the term used for the energy that is stored in an object by virtue of its motion. All objects that are moving possess kinetic energy, whether that is a person on his daily morning run, a moving train, a flying airplane, or the moving planets in our solar system, or our moving galaxy itself, as well as the subatomic world of electrons moving around the nucleus. Let's delve a bit deeper into this to understand it better. The first natural question is, how do we measure an object's kinetic energy and what does it depend on? So as you see on the screen, the kinetic energy of an object depends on and is directly proportional to the object's mass and the square of its velocity. It is calculated using the formula KE equals half times the product of mass and the square of velocity. To understand the implication of an object's mass and its velocity on its kinetic energy, let us take an example of two cars, one which is a regular hatchback weighing 3,000 kilograms and the other one being a large SUV which weighs 6,000 kilograms. Let us first understand the impact of the masses of these cars. Let us assume that both the cars are moving at the exact same speed of 72 kilometers per hour. So let's do this calculation. The cars are moving at 72 kilometers per hour, and we know for kinetic energy we need to calculate the speed in meters per second. So let's do the conversion. We know 72 kilometers per hour is 72,000 meters, and 1 hour is 3,600 seconds, as 1 hour has 60 minutes, and every minute has 60 seconds, so 1 hour is 3,600 seconds. So we divide 72,000 by 3,600, and that comes out to 20 meters per second. Now let's calculate the kinetic energy of the first car, which is the hatchback. For the hatchback, we calculate EK as half times its mass, which is 3,000 kilos into square of velocity. And this is 1,500 into 400. And this comes out to a value of 600,000 or 600 kilojoules. Now let's use the same method to calculate the kinetic energy of the SUV. And the SUV's kinetic energy is half times its mass, which is 6,000 times square of 20, which is 400, which is 3,000 into 400, and that is 1,200,000 joules, which is 1,200 kilojoules. So you can see that the kinetic energy of the SUV is twice that of the kinetic energy of the hatchback, and we can see that its mass is also exactly twice that of the hatchback. So we see that when two objects are moving with the same velocity, an object that has twice as much mass will also have twice as much kinetic energy. And this is because more energy is needed to move that object at the same velocity, as it is heavier. Now let's consider a different scenario where we have two similar cars, each weighing 3,000 kilos. But one of the cars is moving at a speed of 72 kilometers per hour or 20 meters per second, while the other is moving at half that speed, which is 36 kilometers per hour or 10 meters per second. Now let's calculate the kinetic energy of both of these cars using the formula. So for the first car we can say EK is half times the mass, which is 3,000 kilos into square of velocity, which is 20 square, and that is 1,500 times 400. Or that is 600,000 joules or 600 kilojoules. Now let's calculate the kinetic energy for the second car. So EK equals 1/2 into 3,000 into 10 square, which is 1,500 times 100, or that is 150,000 joules, which is 150 kilojoules. So now we see that when the mass of both the cars is the same, and one car is moving at twice the speed of the other, the kinetic energy of the first car, which is moving faster, is 4 times the kinetic energy of the second car, which is moving at half the speed of the first car. Therefore, when a car is moving at twice the speed, its kinetic energy increases by 4 times as much. This is because kinetic energy is proportional to the square of velocity. Intuitively, you can think of it as even when the cars have the same mass. To make a car move faster, a lot more energy is needed, and that is why the car that is moving faster has a much higher kinetic energy. I hope these 2 examples give you a better understanding of kinetic energy and its calculation. This brings us to the end of this lesson. Please practice a lot of questions on this topic and come back to the video if you get stuck anywhere. Until then, thank you and see you in the next lesson.